In this lecture, we will see what is ensemble learning. So, this ensemble learning will see this concept based on the one example. So, when you want to purchase a new car, you walk up to the first car shop and purchase one based on the advice of the dealer. It's highly unlikely, right? मीन्स अगर आपको को कार परचेस करनी है तो आप डायरेक्टली शॉप में जाओगे और उन्होंने जो भी एडवाइस की है डीलर ने वही कार परचेस करोगे. दिस इज़ अनलाइकली, राइट? इट वोंट हैपन कि हम लोग डायरेक्टली जाएंगे. सो व्हाट वी विल डू, हम लोग क्या करेंगे कि जो भी फ्रेंड्स है या फिर कलीग्स है उनकी वोटिंग लेंगे, उनका ओपिनियन लेंगे और उसके बाद डिसीजन करेंगे कि कौन सी कार लेनी चाहिए, राइट? सो यू लाइकली ब्राउज़र फ्यू वेब पेज या फिर हम लोग कुछ वेब पेजेस पोर्टल हम लोग देखेंगे, उसके ऊपर प्राइजेस कंपेयर करेंगे, मॉडल कंपेयर करेंगे, फीचर कंपेयर करेंगे, फ्रेंड्स से पूछेंगे, कलीग्स से पूछेंगे और उसके बाद कुछ कंक्लूजन लेंगे, राइट? So you would likely browse a few web portals where people have posted their reviews and compare different car models, right? So checking for their features and prices. You will also probably ask your friends and colleagues or their opinion. In short, you won't directly reach to a conclusion, but will instead make a decision considering the opinions of other peoples as well, right? So ensemble model in machine learning operates on the similar idea. So they combine the decision from multiple models to improve the overall performance. So let's understand this concept using an example. Suppose you are a movie director and you have created a short movie on a very important and interesting topic. Now you want to take preliminary feedback. ओके, रेटिंग आपको चाहिए आपके मूवी के ऊपर बिफोर मेक इट पब्लिक. So what are the possible ways by which you can do that? So first, you may ask one of your friend to rate the movie. Now it's entirely possible that the person you have chosen love you very much and doesn't want to break your heart by providing 1-star rating. Okay. सेकेंड केस मीन्स आपने हॉरिबल मूवी की है लेकिन दे डोंट वांट टू ब्रेक आवर हार्ट, सो टू गिव बाय गिविंग अ 1-star rating, right? Second condition is what? Another way is you can ask 5 colleagues of yours to rate your movie. This should provide a better idea of the movie, but in this case also this method may provide honest rating for your movie, but a problem still exists. These 5 people may not be subject of matter experts on the topic of your movie. Sure, they might understand the cinematography, the shots or the audio, but at the same time may not be the best judge of dark humor, right? And third choice, it may happen that how about asking 50 people to rate the movie, so some of which can be your friends, some of them can be your colleagues, and some may even be total strangers. So the responses in this case would be more generalized and divertised, since now you have people with different set of skills, and as it turns out, this is a better approach to get honest rating than the previous cases we saw, right? So we saw 3 types of cases, and from that 3 types of cases, last one, that is we can consider it as the honest rating or the best case. So with these examples, you can infer that the diverse group of people are likely to make better decisions as compared to the individuals, right? So similar is true for a diverse set of models in comparison to a single models. So this diversification in machine learning is achieved by a technique called ensemble learning. So simple ensemble learning technique can be max voting. So the result of max voting would be something like this. So colleague 1, there are 5 colleagues, final rating would be 5 4 5 4 4 4. So you can consider the these predictions as taking the mode of all the averages. So averaging, we can consider the predictions. So how we can average? By adding all divided by the 5. So final rating would be 4.4. Now what will be the weighted average? So weights are given like this, 5 weights. So the weighted average can be calculated by multiplying weighted average with the average. So that would be 4.41. Okay. So there are two techniques by which this ensemble learning would be implemented, by using the bagging and boosting. So from that, first we will see what is bagging. So bagging, we also called it as a bootstrapping. So is a sampling technique in which we create a subset of observation from the original data set with replacement. So here you can see the scenario. This is the original data set and we are dividing this into the number of subsets with the condition with replacement, right? So the size of the subset is same as the size of the original set. Subset की भी size same ही होगी as the original data set. Okay. So bagging is a technique uses the subsets or the bags to get a fair idea of distributions. So complete idea लेगी distribution की in one bag. The size of the subset created for bagging may be less than the original set. So multiple subsets are created from the original data set, selecting observation with replacement. A base model is created on each of these subsets. Okay, so base model हम ये लोग क्या करेंगे, हर एक subset के ऊपर create करेंगे, which we will call as a weak model. The model run in parallel and are independent of each other. The final predictions are determined by combining the prediction from all the models like this. So from all subsets different model is created and final prediction will be combined by combining all the models. So in this case the ensemble is built completely. The training process is based on the random selection of the split and the prediction are based on the majority vote. The random forest are an example of backed tree ensemble. So next technique, that is the boosting. So what happened in bagging? We are just dividing the original data set into different subsets and subset with the same or less size as compared to the original data set, and from each this subset will be created with selecting and selecting observation with replacement, and for each subset we are creating a different model which we called it as a weak model. So all the models run parallelly independent of each other, and lastly it is combined to make the final prediction. So this is what bagging concept. Now what is the boosting concept? So what happened in boosting? So before we go further, here is another question for you. If a data point is incorrectly predicted by the first model and then the next, will combining the predictions provide better result? Such situations are taken care by the boosting. If by using the bagging, if data points are incorrectly predicted. Okay, so that can be corrected by the that can be taken care by the boosting model. Okay, so boosting is a sequential process where each subsequent model attempts to correct the errors of the previous model. So what happened in bagging, parallelly run होते थे, यहाँ पे क्या है, sequential model है, तो यहाँ पे subsequent model क्या करेगा, ट्राई टू करेक्ट करने की कोशिश, एरर जो भी प्रीवियस मॉडल ने बनाए हैं उसे करेक्ट करने की कोशिश करेगा नेक्स्ट मॉडल. So boosting is a sequential process where each subsequent model attempts to correct the errors of the previous model. The succeeding models are dependent on the previous model, right? So let's understand the way boosting works in below steps. The subset is created from the original data set. So initially all data points are given equal weights. A base model is created on this subset. So this is the subset. So this model is used to make the prediction on the whole data set. So एक मॉडल क्रिएट किया हमने, बेस मॉडल ऑन द सबसेट, और अभी उसे क्या करेंगे हम लोग, एरर फाइंड आउट करेंगे और उसके बाद नेक्स्ट मॉडल उसके ऊपर बिल्ड करेंगे टू ओवरकम द errors of the previous model, right? So errors are calculated using the actual values and the predicted values. The observation which are incorrectly predicted are given higher weights so that it can be identified. So in this below we can see the misclassified blue plus points will be given higher weights, right? So another model is created and predictions are made on the data set. So this model tries to correct the errors from the previous model. Similarly, multiple models are created, each correcting the errors of the previous model. So the final model, that is the strong learner, is the weighted mean of all the weak learners. So, thus boosting algorithm combines the number of weak learners to form a strong learners. The individual model would not perform well on the entire data set, but they work well for some part of the data set. Thus, each model actually boosts the performance of the ensemble. So, likewise, we can overcome the drawback of the bagging using boosting techniques. So in next lecture we will see the algorithm based on this bagging and boosting.